When one object slides directly over another and perfectly hides it, we are looking at an exact physical duplicate. In mathematics, we call this congruency. It means two objects share the exact same shape and the exact same size. While this applies to physical objects like coins, it also applies to abstract geometry. Specifically, we use this principle to evaluate triangles. Our objective is to learn how to prove two triangles are identical twins, and we are going to do it without having to measure every single side and every single angle. A standard triangle has 3 sides and 3 angles. Measuring all 6 of those components manually to check for a perfect match is slow and inefficient. Instead of checking everything, we use specific criteria. These are patterns that require only 3 measurements to confirm a full match. Our first pattern is SSS, or side, side, side. If all 3 corresponding sides match, the triangles are congruent. Next is SAS, or side, angle, side. Here, we verify 2 sides and the specific angle positioned between them. The third option is ASA, angle, side, angle. We look for 2 matching angles and the side connecting them. Finally, for right angle triangles, we use RHS, right angle, hypotenuse, and side. We confirm the 90-degree angle, the longest side, and 1 remaining side. Using these 4 specific shortcut patterns eliminates guesswork. They provide the mathematical proof that 2 shapes are identical. Let's apply this. This diagram shows triangle ABC and triangle PQR, with a few provided measurements. We need to determine if they are congruent. Step 1 is setting up our formal documentation. We state exactly what we are comparing in triangle ABC and triangle PQR. Looking at the diagram, we can see side AB is 5 centimeters and side PQ is also 5 centimeters. We write that down on the left. AB equals PQ equals 5 centimeters. We add a check mark and label it side. Next, we check the angles connected to those sides. Angle B is 60 degrees, and angle Q is also 60 degrees. We log that match. Angle B equals angle Q equals 60 degrees. Another check mark, and we label this one angle. Now we need one more piece of evidence to complete a pattern. Side BC is 6 centimeters, and side QR is 6 centimeters. We record this final match. BC equals QR equals 6 centimeters. We add our third check mark and label it side. Reviewing our list on the left, we have verified a side, an angle, and a side. This fulfills the SAS pattern. Notice how the 60-degree angle sits directly between our 5 centimeter and 6 centimeter sides. The angle must be positioned between the 2 sides for the SAS pattern to work. Because our evidence fits the pattern, we draw a line and write our conclusion. Therefore, triangle ABC is congruent to triangle PQR by the SAS criterion. By following the SAS blueprint, we have used 3 specific measurements to confirm that these 2 triangles are identical. To recap, congruency means 2 shapes are duplicates. You can prove this using one of 4 patterns: SSS, SAS, ASA, or RHS. There is a common mistake you need to avoid when writing your final answer. The order of your letters matters. You must follow the rule of corresponding vertices. The order of the letters in your final statement must map to the matching angles of the triangles. Triangle ABC congruent to triangle PQR is correct because angle A maps to P, B maps to Q, and C maps to R. Writing triangle ABC congruent to triangle RQP is incorrect because the letters no longer align with the matching parts. True mathematical mastery requires both finding the correct evidence and reporting it with absolute precision in your final answer.